Alright, so we're looking at lesson 22 today. We're going to look at the derivative and then the area under a curve. So hopefully after this lesson you'll understand the derivative and the area under a curve. These are actually both calculus concepts, and you'll notice as we go throughout physics that we use calculus a little bit, especially those of you that are taking calculus this year. You'll see how they kind of mesh together. Physics and calculus are used, they have a lot in common. So if we use calculus, we can find the derivative of the function, which is an equation that will allow us to determine the exact value of velocity quickly and accurately at any point on the curve. So we won't have to try and estimate it and see if our answer is close enough to what the book got. We will be able to find it exactly as long as we know what the equation of the curve is. The rule for finding the derivative of a polynomial is actually pretty simple. You're going to take your exponent and bring it down and use it as your coefficient. And then your new exponent is going to be the old exponent reduced by 1. So I'm going to give you a fairly straightforward example. X squared. The derivative, we're going to take this exponent and move it to the front. So that's going to become 2x, and then the new exponent is going to be 2 minus 1, which is a 1. And so that would be your derivative of x squared. So we're going to practice on a couple of problems. We have t to the 5th. This right here, dx over dt, means derivative. So what is the derivative of this? Well, where does that 5 go? It goes to the front. So we're going to have 5t, and then the exponent is going to be reduced by 1. So the 5 is going to become a 4. Okay, we're going to come down to this bottom one, and then I'm going to let y'all do the middle one in just a second by yourself. So this is a t to the 0, because there's not a variable there. So when we move the exponent, well, 4 times 0 is 0. And so that's what you have. It doesn't matter what this t is because it's just going to be 0. So if you have a number, the derivative of it is just 0. For the middle one, I want y'all to try it by yourself, and then we'll go over it. So if y'all need to pause the video, do so. Alright, so we're going to pull the 3 to the front, so it's going to become 3 times 2, which is 6, and then the exponent is going to become a 2. And so that would be your answer. So that's how you take derivatives. So let's look here. The x position in meters of a particle moving along the x-axis is given by that equation. We want to find the velocity when t equals 3. So before we go over this problem, we need to go over how position and velocity and acceleration are related. So position, if you start with position and you take the derivative, you get to velocity. And if you take the derivative of velocity, you get to acceleration. So you need to learn that. Position, velocity, then acceleration. So they give us the position formula. We need to find the velocity. So we need to find the derivative. So one way you can write derivative is x prime of t. That's called your derivative, as well as dx over dt. That's the same thing. And the derivative is going to equal the velocity. Derivative of your position is velocity. So what is the derivative of 4? Well, the derivative of a number is 0. So 0 plus, what is the derivative of 3t? There's an understood 1 here, so we're going to bring it down. 3 times 1 is 3, and then we're going to have t to the 0. T to the 0 is 1, so we don't have to write it. And then plus 5 times 3 is 15, and then t squared, because you have to reduce it by 1. So this is your velocity function. And it says find the velocity when t equals 3. So what is the velocity at 3? Well, we're going to have 3 plus 15 times 3 squared. So 3 plus 9 times 15 would be 135. And then add 3 to get 138. And our units are meters per second. So that would be your answer there. Okay, so now we're going to try another one. They give us the velocity equation, and we want to find the acceleration. So I just told you how they are related, but how are velocity and acceleration related? The derivative of the velocity is your acceleration. So what would be the derivative of 3t squared? It would be 6t. And the derivative of 2t would be 2. And then we have derivative of 4, which is 0. We don't have to put plus 0, although you can. So this is your acceleration equation. And then they say, what is the acceleration at 1? Well, 6 times 1 plus 2 is 8. And then units for acceleration are meters per second squared. So that would be your answer for that. Okay, we're going to look at another example. They give us x of t equals 6 plus 3t squared plus 2t to the fourth. Find the acceleration. So if you think you can do this one by yourself, y'all go ahead, and then we'll go over it. So they give us a position. So the derivative of position is velocity. So what is our velocity equation? Well, derivative of 6 is 0, so we don't need to write that. Derivative of 3t squared is 6t. And then derivative of the next term would be 8t to the third. But they ask for the acceleration. How are velocity and acceleration related? The derivative of velocity is acceleration. So we have to take the derivative again. So what is the derivative of 6t? 6. And what is the derivative of 8t cubed? 24t squared. And so it says, what is the acceleration when t is 3? So we have 6 plus 24, 3 squared. 6 plus 24 times 9 is 216. And if you add 6, you get 222 meters per second squared. Okay, so that's how you can use the derivative. Now we're going to look at area under a curve. So the area under a curve is the distance the object traveled. We already did this a little bit. Remember, if it's above the x-axis, it's a positive. We had a problem like this. This would have been a positive, and then this part would have been negative because it's below the x-axis. Whenever it's composed of straight lines, it's really easy. We've been doing that. You can break this up into a rectangle and a triangle, or you can just use it as a trapezoid. Either one. However, when you have a curved line, we can estimate it, but we won't have the exact answer because we're missing these pieces here. So it'll be an estimate, but it won't be the exact. And so you're going to use calculus to find it exactly. So to find the exact area under a curve, we're going to use something called the integral of a function for whatever time interval they give you. And so to find the integral of a polynomial, you're going to increase the value of your exponent by 1 and then divide by the new exponent. So if we start with 2t to the second, you're going to add 1 to your exponent, so it's going to become 3, and then you're going to divide by the new exponent, which is a 3. And you always put a C when you're dealing with it in calculus. Although if we're doing area under curve, we're not going to be doing a C because we're going to have a number here and here to plug in. Same thing here. Right now we have a t to the 0. So when you add 1 to the exponent, it's going to become a 1. And then you could divide by 1, that's still just 4. So the c is the constant of integration, and it's used more so in calculus, but we could use it in this class if they just ask you to integrate. But again, when you have a number here and here, you're going to use those and you won't have the constant of integration. In calculus, they put a dt behind the function because that means that we had taken the derivative with respect to t, so that means that t is our variable. So pretty often they'll put the dt in your problems. I do want you to get in the habit of putting the dt or dx or whatever variable we're dealing with. So to find the area between the curve and the t-axis between 2 seconds and 4 seconds, you're going to evaluate the integral. And so this is your integral. This is what it's going to look like. Our curve is 2t squared, and it says between 2 and 4. 2 is the lower limit, and 4 is the upper limit. We're going to travel in between 2 and 4 seconds. And the answer that you're going to get is called the definite integral. So when we get our answer, we have found the definite integral. So I'm going to show you how you work through this. They give us the position, no, they tell us the position of an object that moves on the x-axis when t equals 0 is 42. The velocity of the object is 4t squared minus t meters per second. Where will the object be when t equals 3? So they gave us the velocity, and we need to know about the position. So remember that the derivative of position is velocity. And so we're going to go backwards, and that's called integration when you're going backwards. So we're going to do 4t squared minus t with respect to t. And we're going to go from 0 to 3 seconds because that's what we're concerned with. We started at 0, and it says when the object's at 3. And so we're going to have to integrate this. So when you integrate, you add 1 to the exponent, so that's going to become t to the 3rd, and then you divide by the new exponent, so 4 over 3. For this next term, there's a 1 right now, so when you add to the exponent, you're going to get a 2, and then you're going to divide by the new exponent, so it's going to be an understood 1 over 2, so 1/2. And then we're going to evaluate it from 3 to 0. Okay? So that's what you start off with. From here, you're going to plug in the 3. So you're going to have 4/3 and then 3 cubed minus 1/2, 3 squared. And then you're going to subtract and plug in the 0, whatever your lower limit is. So you always plug in your upper limit, subtract, and plug in your lower limit. And from here, it's just algebra simplifying it. So 4/3 times 3 cubed is going to be 36 minus 9/2 minus 0 minus 0. So both of those terms are 0. So 36 minus 9/2 is 31.5. And so that's the distance that it traveled. However, it didn't start at the origin, it started at 42 meters. So the total, or the position, if it started at 42, we're going to add 31.5, which is going to give us 73.5. And how many sig figs are we going to have on this one? Tom only had 1 sig fig here. This one had 2, so we're going to have to go with 1 sig fig. So 70 meters would be your answer. So for those of you that have not taken calculus, you may want to ask someone that is in calculus right now to help you go back over this if you had trouble. You may also later this evening when you're working on your homework, or tomorrow, rewatch this part of the video to go back over it. But that's basically what you do to integrate. You're going to just integrate your function by adding 1 and dividing by the new exponent, plug in and subtract, and then simplify. So hopefully that helps you a little bit with lesson 22. Your homework is 1 through 20 and the curveball questions. So make sure y'all do those tonight so we can go over your questions tomorrow.